What we're going to look at right now is how to solve quadratic linear systems of equations. Now, one of the units we do in my classroom is systems of equations. Basically, I give you two linear equations and we have to figure out the x and y values that works. And we had three different methods to solve it. We could use graphing, we could use the method known as substitution, or we could use elimination. Now, solving quadratic linear systems, when we get into it, there are only two options that we can use. We can only use the graphing method, or we can use substitution. Today we're going to look at the graphing portion of it, and then we're going to get into the substitution bit at a later time. So, first things, we're going to have two equations. One is going to be quadratic, one is going to be linear. So quadratic has a degree of 2 because it's x squared. The linear equation has a degree of 1. So again, the standard form for a quadratic equation is ax squared plus bx plus c equals 0. And then the linear equation, we're used to the format y equals mx plus b. So we're going to have these two formats that we're going to be dealing with, and we have to basically figure out the x and y values that would make our equation true at the same time. So they say we have to create a table of values for the quadratic equation and graph the linear equation using the y-intercept and slope. Where the two graphs meet, this is your solution. So just like the system of equations with lines where the two lines crossed, that was the answer. In this case, it's the same thing. Wherever my parabola and my line cross, that's going to be my solution. Now, when I graph lines, there were three possible situations. I could have no solution, I could have one solution, or I could have infinite solutions. When it comes to quadratic linear, there are also three possible solutions. One would be 0 solutions. So what this looks like is we have a parabola. So there's my parabola, my quadratic equation. And then my line would be off to the side somewhere. So notice that these two do not meet, they don't cross, they don't intersect anywhere, so there's no solution. Now we could end up with one solution. So again, this is something like, here's my parabola, it comes down, back up, so there's my arrows, there's my parabola, and then the line, the way the line would work is it comes up and it just touches my parabola in one spot. So that one point of intersection is going to be my solution. So right here where they meet, there's my solution. And we could also have two solutions. So we're going to end up with 0, 1, or 2 solutions. And the way this works is relatively simple. We have our parabola, and then we have a line that runs through it, and we end up in 2. We end up having 2 points of intersection. Right there would be our solution, and here would be our solution. So those 2 points where my parabola and line cross, that would be 2 solutions. So those are the 3 possible situations we could come up with. More often than not, we're going to end up with 2 solutions based on our equation, but it is possible that we end up in a situation where we have 0 or 1 as well. So what does that look like graphically? So we're going to solve the following system of equations graphically and check. So first things first, just as with all equations when I graph, we like them to be in y equals form. So as long as they're in y equals form, we're good to go. So my first equation, y equals negative x squared plus 4x minus 3. That's good. We're in y equals, it's quadratic, so we're all set with that. However, I take a look at the second one, x plus y equals 1. It is not in the y equals form, so we have to make it so. So we want y to be itself by itself, so we have to move the x over. So we're going to subtract x, and we end up with the equation y equals 1 minus x. So now that we're in y equals, this is the form I am going to use. So what we want to do now is we want to graph it. So by going to y equals, we can plug in our quadratic equation, negative x squared plus 4x minus 3. We're going to go to the table. Again, we can look at the graph. It's going to show us what the graph looks like, but it doesn't give us any points. So we want the table being in yellow. So second graph, we'll get the table. And I want to look for the x and y values. I want to get the y values that end up repeating. So here we wrap around from -8 to -8. So here we are with a good viewing of what points are going to create our parabola. So -1, -8, left 1, down 1, 2, 3, 4, 5, 6, 7, 8. Zero, -3, so right on the origin, down 3. 1, 0, so right 1, right on the x-axis. 2, 1, so left 2, up 1. And then we start repeating. So 3, 0, 4, -3, 5, -8. So here we have a good showing of what our parabola looks like. Comes up, curves, back down, arrows at the end. So again, drawing doesn't have to be perfect as long as we got the points dotted and our parabola is running through it as best as we can. Now y equals 1 minus x. So if we look at our format, y equals mx plus b. Slope is always with x. B is always the standalone number. So the standalone number in our case is 1. And then our slope is on x, so negative. So -1 over 1. So we can use this to plot our points. So we always start with our y-intercept at 1. And then we go down 1, right 1, 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 down 1, right 1. So there is the points that we are looking at, and we can run right through it with our line. Arrows at the end. So what I want to look for is the points of intersection, and I see we have point of intersection right here and right here. So we actually have two solutions. The first solution is 1, 0. So I go right 1, I'm right on the x-axis, so 1, 0. And then the other one, I go 1, 2, 3, 4 to the right and down 1, 2, 3. So 4, -3 are the two solutions based on our graph. We could also plug in our other equation, 1 minus x. Again, look at the table. And what I want to do is I want to see which x values give me the same y value. So notice so in here we had two equations, y1 and y2. So this means I'm going to have two y values as well, y1 and y2. So y1 are the y values for our quadratic equation, and y2 is the y values for our linear equation. And I want to see which points have the same y value. So notice we have y values of 0 and 0, hence 1, 0 being our answer. And then here we have y values of -3 being the same, hence 4, -3 is going to be our other solution. So we could check the table that way. So that is graphing and seeing where we intersect our parabola and our lines. Now, If we want to truly check, sometimes we don't have nice intersections, we can use this method, second trace, and I'll show you with this second particular problem. And it's kind of wonky, so if you haven't seen it before, you're going to be slightly confused. Basically, it's just hitting a bunch of buttons, and you get the point of intersection from your calculator. Now, solve the following system of equations graphically and check. So first thing are my equations: y equals x squared plus 4x plus 4. We're good there. And y equals negative 2x plus 4. So that one's also good. So what I want to do is I want to graph or plug in our first quadratic equation: x squared plus 4x plus 4. And I go to my table and I look for the y values that repeat. So we repeat 9 back around to 9. So I'm going to plot these points. Negative 5, 9. So 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 4, 4. So left 4. Up 1, 2, 3, 4. Negative 3, 1, left 3, up 1. Negative 2, 0. And then we start repeating. Negative 1, 1, 0, 4, 1, 9. So here's the parabola of my quadratic equation. So it comes down, back up, arrows at the end. And then I'm going to graph the linear equation negative 2x plus 4. So y equals mx plus b. So m is always with x. So my slope is negative 2 over 1. Whole numbers are always over 1. So rise over run. And my y-intercept is always the standalone, which is a positive 4. So I'm going to plot a point at positive 4. And then I go down 2, right 1, down 2, right 1, down 2, right 1. So I'm going to draw my line running through my points, arrows at the end. Now in this case, it looks like we only hit one spot. In this case, it's 0, 4. So 0 up 4. So now it looks like there's only one based on our graph. Now it's not true because my parabola keeps going up forever and ever. My arrow keeps going, my line goes forever and ever. So we actually have to check to see if it hits a second point. So we had x squared plus 4x plus 4, and I want negative 2x plus 4. So I go to my graph, and we already know that when x is 0, I get 4. Now my arrows are going off to the left, so I want to keep going up into my negatives, and I see my y values have the same answer when they are 16. So what x value gives me an answer of 16? Negative 6. So the other point of intersection is negative 6, 16. And again, it doesn't show on our graph because we don't have 16 lines on our graph. We only got 10. But we can use our calculator to see the other values if it goes beyond what we physically have on paper. So we still have 2 solutions. There are still 2 points of intersection. And if you truly wanted to check it with our calculator, there is a way that we can do it. As long as they're both plugged in, we look at we have our graph, and we can see that it's. Now we already know that it intersects in 2 different spots. So we actually want to change our window. So x min, x max means how far left and right. So we go from negative 10 to 10 on our x-axis. Now the y min means bottom, negative 10. Same with y max is also 10. However, we already know that we have to go to at least 16. So we can change our y max in our case to 20. So once we do that, if we take a look at our graph again, notice the top part is a little bit larger than it was before, and we can actually see both points of intersection. If you truly want to check it to make sure that you are correct, yes, we looked at our table, so we know they are correct. But once in a while, we get a really wonky situation where they don't intersect at nice places. In our case, they did, but the method to do so is up here in our nice little chart here. Second trace. So notice above our trace button here, we have yellow, calc in yellow. That basically means calculate. So we're going to hit second trace, and we want to find the point of intersection. So it's actually number 5, intersect. Now, what we want to do is move the cursor around the point of intersection so we can see. We're going to be on the left-hand side a little bit. So first curve, question mark, we just hit enter. And then the second curve, we go to the right a little bit and hit enter. And then it'll say question, it'll say guess question. We just hit enter, and it's pretty close to 0.4. So negative 1.43 times 10 to the negative 13th. It's really negative 0.000143. So close enough to 0.4. Now the other way we can do it, again, second trace, number 5 is calculate, and we're actually going to go over to the left around our curve, and it's just going to follow the curve. Notice the cursor. Once I'm almost to the point of intersection, I'm close enough, I hit enter, and then it'll say second curve, so I go to the right a little bit, hit enter, guess, question mark, intersection, negative 6/16. So notice we got the same answer as before. So that is using the calculator when we don't have nice points of intersection. In this case, we did at 0.4 and negative 6/16. Three, graph of the equation y equals x squared and x equals 2 intersect in how many points? Well, y equals x squared. We're good with that. So we go to y equals x squared. If we look at our graph, we get a nice little parabola there. So here we have a graph. We know x squared looks like this. So there's my x squared. X and y axes. X squared is a nice little parabola. X equals 2. Now, before we said we like our lines to be in y equals mx plus b format. Once in a while, we end up with a situation where we're told our linear equation is x equals 2. So we actually had 3 types of line. We had a diagonal line, which is our y equals mx plus b. So there's our diagonal line. We have a y equals a number. This is actually going to be a horizontal line. And every once in a while, we're told x equals a number. This is actually the vertical line. So this goes back to learning how to graph lines. Y equals mx plus b. We're going to be having a diagonal line. Y equals a number, horizontal. X equals a number, it's a vertical line. So I'm actually going to have a vertical line through the x value of 2 here. So there's my x equals 2. How many points did I run through? Well, in this case, it was only 1 point. Sweet. Now, number 4, again, multiple choice. What's the solution to the following system of equations? As long as they're y equals, I can plug them in. So y equals 2x minus 15 and y equals x squared minus 6x. So we go to y equals. Our first equation is y equals 2x minus 15. And our second equation is y equals x squared minus 6x. And I want the solution, so I need points. So I'm going to go to the table, and I'm going to look for the y values that end up being the same. So we're not even really remotely close here, so I'm going to be going down further. So notice values are getting a little closer. So here we have y values of -9 being the same. So x equals 3. So 3, -9 will be a solution. So is that one of my answers? Yes, number 1. And then last but not least, 5 is the same thing. When the graph of the equations y equals x squared minus 5x plus 6 and x plus y are drawn on the same set of axes, at which point do the graphs intersect? So again, same thing as before. We want to plug them in on the calculator to see which x and y values are the same. So as long as they're y equals, we're good. First equation, y equals, that one's okay. Now x plus y equals 6. That's not okay because it's not y equals. So I want to move the x over. So we're going to subtract x. And our equation is actually going to end up being y equals 6 minus x. So these are the two equations that I'm going to plug in to the calculator in order to figure it out. So we go to y equals. First one is x squared minus 5x plus 6. And then our other equation is 6 minus x. And again, I want to go to the table because I want to see points of intersection. So I want to see values that end up being the same. So here we don't see any repetition until y values of 2 are the same. So what's the x value when y is 2? 4, 2, which ends up being number 1. So 4, 2 is the answer to this one. So this is graphing quadratic linear systems of equations. We want to graph the quadratic equation and the line on the same set of axes, and we want to see where they intersect. So just like the 1 and 2, we end up having 2 points of intersection, therefore we had 2 solutions. And we just list the x, y points of those intersections.